All right, welcome everybody. We got second session for the Enterprise One Technical Task Force for the month of April. Welcome back, and it's good seeing everybody collaborate. So this month we have Chris Papineau on to revive his performance series, Tales from the Performance Queue, which Chris manages on a daily basis. So a couple of quick notes, please, everybody. Mute your lines. I believe Chris likes having questions at the end, so you can log them in the chat and we can bring them up. If you have any other questions or concerns, I can try and address them during the session as well. So again, Chris Papineau will be talking this month. We'll be sending out the next meeting invite for the month of May. It'll be AJ Schifano to talk about the Internet of Things Orchestrator Studio and all the new happenings with that. So again, we've got a full slate of items that we'll be covering on these sessions, and a lot of good content, so keep coming on board. So without further ado, Mr. Papineau, take it away.
All right, thanks. Yeah, Chris Papineau. Some of you that are online, I'm familiar with you. Some of you are familiar with me. Some of you not. I'm a J.D. Edwards, PeopleSoft, Oracle person of 21 years who's worked for all three companies but hasn't changed his phone extension since 1995. So that's me. Most of those years, maybe 15 or 16, I've done performance. Maybe you're familiar with Tales from the Performance Lab and the Performance Queue. Some of those I've done in past instantiations of this. And other ones of these sessions I've done that deal mainly with case studies, but really the title is inaccurate. Now we're dealing with the performance world. Okay, if I can get here's our usual disclaimer. This isn't guaranteed or anything like that, or it's not intended as future direction, but we are dealing now in performance world that goes beyond Performance Lab and Performance Queue and whatnot. So what I've got here is a couple of case studies. One from the customer queue, like the original title suggested, another from an internal project, okay, that the reason we do these case studies is so that you have generally applicable takeaways, lessons, things that might apply to other types of problems in other situations. I've marked them with a little takeaway sign. And I will provide PDF copies, by the way, of these slides to Clayton and whatnot. Like I think most of the slides from most of these sessions are available to you. I'll make these available to you as well, so you don't have to scramble taking notes. I also might note that the great many, several dozen past presentations from both these sessions and other sessions we've done in Performance Series are in the Performance Library at that doc ID indicated below. So you know that is available. All right, so the agenda is two different parts, two different case studies. The first one, we'll call it a customer case. We'll call it the Ghost of Platform Future. I can get my mouse to work here. So basically, you've all seen the movie Inside Out last year, which was motivated in large part by people trying to run big UBEs and not having enough memory, right? If you haven't seen the movie, that's what it's all about. All right, so what I always hammer on people, like you saw in the initial slide, is problem definition. You can't go and say everything is slow or everything is slow across the board. You'll know that's the quickest way to get me to say, I'm closing your case till you go and give me a more specific definition. Well, here we have a customer that upgraded from XE to 812. Yes, XE still exists. This was a recent case. They weren't able to run the MRP UBE, and in their JDE log, they had a memory allocation failure indication. The upshot here is the customer was running this, the job failed, okay, ran out of memory. Now, takeaway here, something the customer did that's good in this case. They first looked at the JDE log, okay, rather than just saying, oh, the thing fell over. Thing ended in an E status instead of, gee, I like a P when it ends there. I like it when it's running in D. Okay, those are good for UBEs, but it ended in an E. So what happened? Well, again, the JDE log often has high-level things that can short-circuit a lot more complicated and detailed and painful analysis. Sounds obvious, but it's something that often people miss. So they looked there, they found the memory allocation error, okay? Second thing to look at is 812 uses a whole lot more memory than XC. The reason is that 812, it was a move to Unicode for virtually all the application and tools code. Unicode is, of course, a move from single byte characters to double byte to multi-byte, supporting, all the languages we support, within that code set. So you're going to have a bigger footprint. Another material fact here that's very significant in that not only did they move from XE to 812, but also from iSeries to AIX, which is IBM's version of Unix. That is a platform change, and that can be very significant because, things work very different. There's a number of things very different about the models, memory models and whatnot. Okay, so the customer logs provided, they claim the memory failure occurred after only a few minutes of runtime. Now notice that the debug log is in multiple segments. There's one that has the UBE and the process ID, and then the same thing with an _1 there too. Okay, now the reason for that is how your logging settings are generated, and we'll look at that. Second, looking at the JDE log in a little more details, we can see that the job ran for over 9 hours before the memory allocation occurred, simply by looking at the start timestamp, and then what's the timestamp for when the memory allocation occurred? Well, it was 9 hours later, okay? So that JDE log, again, which is always generated, tells you something. Now, the debug log that we did receive didn't record 9 hours of data. It only recorded about 3 minutes of runtime. Okay, we were able to determine this by running a tool called Performance Workbench, which is our own internal tool that goes and parses customer debug logs or any debug log from UBE's kernel jobs and makes kind of a profile out of it. Tells you how much time was spent and where. It's a very powerful tool. This session won't get into the details of how to use that tool, how to use the outputs. Many of you probably know and are familiar with it. I put a doc ID out there that tells you where you can get it, okay? And it's got detailed help files. There's also in the performance library, there's docs out there that give case studies, examples, how to use it. But meanwhile, let us put that as a takeaway, that is something to do with logs other than just opening them and trying to read them, okay? This parses it and gives you a much smaller, compact summary of what's in there, including the total time, which is, again, less than 3 minutes. So we don't have a debug log that contains debug information for anything like the entire run, okay? What we had is we had the debug log with the _1 index and a smaller one that didn't have the index. Now, the reason we get that deals with a couple of INI settings that deal with how logs are created. One of them is the max debug backup index. That setting was 1, which means that the debug log, when it reached its maximum size of 1 gig, and by the way, that's set by another setting, max debug file size of 1 gig, only 1 backup index log will be created. And when that fills up, the debug log gets overwritten. Okay, so at the most, you're going to have these 2 segments constantly getting overridden as more and more data gets kicked out by this UBE running what it does. Again, the settings are there. They also appear in Server Manager. Those same settings can be set there. And you can see I took this off of Server Manager where it shows the settings the way I like to have them, a 2 gig max size, 20 prior debug logs. So it covers most any of the processes I run to not write over everything, to give me a complete picture of everything. So again, with 3 minutes of runtime, we generated over 1 gig. So we can see that collecting logging for anything like a full run of 9 hours is very impractical in this case. And that's why, as an aside note, you might try to run something like 20 or 30 minutes as a compromise between sample size and practicality. That's another whole topic altogether. Okay, we're not going to tell them to do that here. In any case, the UBE, not only does it not fail minutes into the run, it fails several hours into the run. Okay, If you've seen any of my presentations in the past, you know I like to quote Gregory House from the TV show that ran for 8 seasons a few years back. You want to think about what's being said. You also want to realize something very important, and that's that everybody lies, right? Or more specifically, you can't assume that what you've been told is accurate unless you verified it. You know, the quote, who knows where it came from? I like to say, if your mother tells her she loves you, check it out. Get a second opinion, okay? They said, well, this thing fell over minutes into the run. And then they assumed that for hours it was just kicking out, you know, erroneous information, whatever. That's not what happened. Okay, what happened is it ran for 9 hours before it filled up the memory and then fell over. When you looked at the logs, you could see that. You could also see that the debug log was not for 9 hours, but their debug log settings, which they weren't aware of, just kept overwriting the same gig every time. And so you've got this window of 3 minutes of time, some moving window, and all we were really getting is the last 3 minutes of the run. Okay, so obviously 3 minutes is not a valid sample size to do full analysis, but still worth taking a look at what's in there, right? Long as they kick this 1 gig thing out, why not take a look at it? Well, how is it that in general terms you look at what uses memory in a process, having a JDE debug log of that process? Well, it's having a little bit of knowledge of how the code is structured helps. And the most common, although not by any means the only thing that uses memory at an application code level is lots of user caches, okay? Lots of user caches. And just as a very broad thumb technique, Performance Workbench will, at the beginning of the log, list all of the times and places that JDE cache operations were performed. Particularly, you want to look at JDE cache adds, because JDE cache adds is what uses that heap memory of the process, okay? Particularly if you don't have deletes to go with them, okay? It's a very broad, you know, look at things, but it gives you a general idea. And when we look at this particular log, this 3-minute sample, we see, you know, 7,600 records were added to a particular cache in this particular work order routings edit dot business function, okay? Those are all the cache operations, okay? They occurred only in 3 business functions in the sample. One of them was doing a bunch of adds. Don't see deletes. Okay, well, is that a memory leak? Well, again, this brings me to another important topic for which out there in the performance lab there is a another presentation that has this title, or the title is Memory Issues in Enterprise 1, something akin to that, in which the thrust is just because something is consuming memory does not necessarily mean it is leaking memory, okay? Because some jobs, just by their nature, have a big footprint. MRP is one of those. MRP is a job that runs, this particular job, when they didn't run debug logging, ran for 4 or 5 hours, you know, around 9 when they had debug logging on, okay? And this job makes calculations and does work based on tables that have a pretty big footprint, and it stores, you know, information from those tables into corresponding user cache objects, which are also very big, have a lot of memory, okay? It's a commonly used application. A lot of customers use it. It is an old, not meaning useless, but meaning a legacy application. It's been there for a long time, and it's not one that we see constantly crashing out of the sites, okay? In other words, the program works, okay? It does what it's supposed to do. So your heuristic kind of eyeball test, as I like to call it, sometimes analysis, there's not strong evidence for a true leak here. Yes, MRP consumes memory, okay, but is it necessarily leaking memory? Well, you know, that's not something, that's not a tree we're going to bark up at this point. And again, the takeaway I put here is all of that information on this slide is based on product knowledge, kind of experience, which is, you know, an important thing to get. Not that you can't go and do performance analysis having maybe thin product knowledge, but it is much better if you have it. And your analysis becomes better and quicker and more efficient. The more you know about the app, the more you know exactly what witch hunts to go on and what doesn't. It kind of helps with your initial path. If you get a general compass bearing that points you, you know, north by northwest instead of south by southwest, you're going to have to circle around a lot at times. So, all right. So, You know the source of the numbers, but what do they mean? Another one of my favorite movies, characters, Indiana Jones, okay? You're looking for things. You're looking for that treasure that's buried into the dust somewhere. So what does the memory allocation error really mean? It means the process used more memory than a 32-bit system will allow. Okay? It doesn't mean that adding more memory to the machine itself is the solution. You'd be surprised how many folks, how many IT folks, how many folks or customers try to do that. They see this, so we can add more memory. Like, well, it doesn't matter how much memory you add, you're not going to be able to use it, okay? It's like adding a stronger engine to a car to get you through traffic faster. I always like to say that I can buy a Lamborghini that can do 190 miles an hour, but if my problem is rush hour traffic, it doesn't matter. I'm going to be right beside the Yugos, okay, and stop and go traffic. Okay, the problem isn't memory in the machine. The problem is the process is using more than memory, and usually that means 2 gigabytes, right? But really, can you say that? No, because the platforms have a different way that they allow processes to use memory, and this is where the platform difference comes into effect. Okay, this is the crux of the problem. AIX, which is the platform that they switched to, has a very different memory management model than iSeries. iSeries is a little bit more painless in that respect, in that it uses something called single level storage, which I won't get into the details here. Okay, but again, you have these type of memory problems less often, okay, on iSeries because of the way it does memory. It's a little bit more user friendly, if you will. Now, I'll have to speak with my secretary. I put AIS, that should be AIX down at the bottom here. We are going to talk about something called AIX, or S, in the next case study. But that's neither here nor there. So it should read AIX is different. Okay? So again, you might be consuming similar amounts of memory, but the default OS memory systems on AIX may be a factor here. It may be causing the consumption. Okay, so the AIX per process memory limit, okay, if you look at what its specs are, it defaults to 256 megabytes. That's not very big. Not with the Unicode version of our product with a big UBE, okay? That isn't very big. Now, turns out the good news is on AIX, this is controlled via a Unix environment variable, this LDR to store control. The action item here for the customer was set that to the supported maximum of 2 gig. Okay, that is your 32-bit maximum, okay? And the way you can get that to take is you add it to the .profile, file for the user which runs Enterprise 1. You add those 2 lines there to the file, okay? And that will mean that any Enterprise 1 process that, comes up, kernel jobs, run batch jobs, which are UBE jobs, will then be run with that environment variable allowing the larger memory footprint. You don't need to rebuild the AIX kernel. You don't need to reboot, but you do need to restart Enterprise 1, okay, in order to get this to take for new processes that are started, because you have to have the environment of that user change to have this variable then kick in, and then you'll inherit that value for all other Enterprise 1 processes. So what were the results? Well, you changed the settings from 256 to 2 gig. Now they went 2 cycles in a row, didn't have the memory allocation error. Okay? So again, takeaways there is that, we could have done a lot more detailed work, could have generated bigger logs, do this, do that. But in fact, this was solved fairly quickly within a matter of a couple of days just by the JDE logs, which the customer had insight, just by product knowledge and by looking at, hey, this is probably a significant platform, difference. Okay? Second case study is kind of in 2 parts. I'll call this one memory lane. And you can see we've got all the ADF memories here. What's ADF? But they're all happy memories. Not to worry. More scenes from Inside Out. Again, problem statement here. This is an internal project this time, okay? So we've gone from a customer case study to one of our internal research, our own cutting edge stuff, if you will, in which we are going to analyze an application created using something called the Application Development Framework, or ADF. And it's an app written in this ADF standard, but running in the Enterprise One HTML client, and doing that via a protocol called Application Enterprise Services. That's the AIS thing I talked about, not AIX. You're running a three-letter acronyms pretty soon, you begin mixing them up. Right? AIS, AIX, ADF, CIA, FBI, whatever. But anyway, the ADF application, you can see a rendition of it there, okay, actually runs within the ecosystem of the HTML client. Okay? And it is a Work Center load review calendar, which does a bunch of things dealing with work orders and scheduling work orders, and I could wave my arms about that in the next 5 minutes and not make a whole lot of sense about it, because I know enough about it to be dangerous, okay, about the business end of what this does. But what are these things? Okay, kind of back to truck up here a little bit. Well, ADF, simply put, is an Oracle Java development framework that includes an infrastructure and a visual IDE, a visual development environment. Okay, so it's a newish Oracle standard by which you can develop apps that Oracle is promoting, pushing. Okay, that we are now integrating in with the Enterprise One product and starting off with this Work Center app. And in order to do that, you've got the interface called AIS that uses something called JSON over REST. And we'll get into the details of what that is, but it is a protocol by which you enable communication between ADF and Enterprise One and the Jazz server. And it allows your Enterprise One HTML client to run an ADF application in place as part of that client. So that's to set things up a little bit. Some of the details are here. You can see that in order to run ADF, you need two other pieces besides your standard, Garden Variety Enterprise server and your Jazz HTML server. You've got ADF kind of down here at the bottom, okay. That is a WebLogic managed Java server, and it's got the ADF application code resides there, okay? And what you have here is it then throws its data back and forth to the AIS server, and what it is like a traffic cop, okay? It's another WebLogic managed Java server, excuse me, which communicates via sending servlet calls, and accepting back JSON application data calls, and ADF then maintains its link with Jazz via a handshake session that maintains that session. Okay, so this is a new protocol. This is something that we're going to try to increasingly encourage the use of, to make Enterprise One a more usable, more broadly applicable product by being able to support these standards. And to do that, we want to try to isolate bottlenecks and inefficiencies in all the parts of this system, and by examining the various components. Okay, so phase one of the case study, after setting everything up like that, well, a pretty significant relevant metric for the ADF Work Center use case is a button that we call refresh. And maybe it's not the best name for that button, but and don't think of it as refresh in terms of F5. Think of it as refresh in terms of calculate this calendar and this whole scheduling, workloads. Okay, it's like a big fine button with a lot of logic. When we got this thing set up out of the box, had a response time about 5 to 10 seconds. The long and the short of it is that we wanted to get that 2 seconds. That's what we got back from the strategy folks. So what's going on here is you've got the ADF application. Again, part of its business logic is C business functions running on the enterprise server, okay, just like any of the other apps. That part is familiar. That part we know about, done many times. So what we do is, okay, let's take a look and see how much of this is business functions. You enable enterprise server logging, you run the use case, okay, and then you take that log and you run Performance Workbench. Again, another takeaway here, it's really a repeat of the same takeaway, I would suppose, but it's using Performance Workbench against enterprise server logs that you've targeted with just this one use case. You examine the top level business functions, okay? And looking below here at this list, this histogram of the top level business functions, you can see one stands clearly above the rest. That is a business function called set selection for work center load. 3 calls, took 32 seconds, okay? And that is in 32 seconds with logging overhead. So really probably in real time, it's probably something like 20 seconds or so, which is still 7 seconds or so per call, without logging. Anyway, it's too much time. But there's a very clear place for us to start our analysis. It is in that business function, okay? Now, another takeaway here is realize that what Performance Workbench does is it's analyzing a profile. And what the debug log does is it gives you a profile that has hierarchical structure to it in terms of the call stack that these business functions have. The business functions call child business functions. They get called from other parents' business functions. They call API, tools APIs. They call a SQL, everything else. So the takeaway here is the drill down analysis. Go click on that business function from the list and find out what its children are, where its parents are, and clearly, if you look down the bottom here, 90% of that business function's time is spent in 2 child business functions. Decimal trigger, get my company, and get at 4801 company, okay? Also, the major SQL that it calls, when you get rid of these F98s, because what these F98s are just spec tables. Those are central objects tables that typically get called once. And this was the first time we called this business function. Boom, it loads the specs, you're done. And I can tell you from experience, those typically aren't a big part of your analysis. But what we see in terms of business tables is this 3-table join. And the work table, the tag table, and the 3112, okay? I've also got my Onyx here that, again, drives home the point of your drill down, which means what you're doing is where is the code or system spending its time, which comes down to the 2 halves. Does something get called too many times? Is something spending a big chunk of time in one place? You follow the time being spent, okay, and analyze it till you get to actionable items, and that's what we're doing here. That leads us to these 2 child business functions. We drill into one of them, get at 4801 company. And we see this gets called 5,400 times and has another select into 4801, for every call it makes. That's in addition to the fact that you're getting 4801 records from the join already. So why are we getting the same records twice? What fields are we getting from now this extraneous select that we weren't getting by fetching all those records from the join? Okay, that's one question. Also, we've got time spent in more calls to the decimal trigger function here. Another 6 seconds there. So what's going on there? Well, what I do then is I SQL parse the debug log. Again, that's another tool that is part of the Performance Workbench suite. Again, I won't go into detail into how that works here. That's other sessions. Some of you know how to use it. Maybe some of you don't. There are other sessions, again, in the Performance Library that show you how to do that. But what SQL parse will do is it will take all of the SQL of a table you specify in a debug log and divide it out into kind of a histogram, a cardinality sort of histogram, and it'll say, out of those 5,400 calls, how many were unique calls? In other words, were there 3,000 repeats of one call and another 2,400 that were different? Well, in this case, every one of them were unique. What I'm trying to do is trying to find ways that could you leverage caching in some way? Could you leverage getting the data once and reusing it and storing it someplace rather than fetching from the database repeatedly things that don't change? Because that is one common high expense item. In Enterprise One apps is calls to the database, relatively speaking, they're expensive. They are especially expensive when you fetch the same thing over and over again, but that's not happening here, okay? Because SQL parse shows us that these calls are all unique, okay? So a summary of the big bunch of 100-pound of bricks baggage we have in this business function. You got a 3-table join, okay? Which presumably fetches its rows in a big old loop. You got child business functions. 4801 company and decimal trigger, okay? 4801 company calls to 4801 and then calls more decimal triggers, okay? So you get all this baggage. Now, this is where the other takeaway here is that none of us, or very few of us, are experts in absolutely everything, okay? We've got this profile data. Once again, you got the numbers. Well, what do they really mean? And that's where somebody who knows the code and knows the app, and hopefully, ideally, somebody who's actually written the code, if they're still around here, or somebody who knows, something about it, can help you make sense of that data. So that's where subject matter experts can, make you into a whole lot better of a performance analyst. And if you don't know the code itself, who does? Who can take a look at this and say, yeah, that's what that means? Okay, well, what we got there is that this entire code path is due to currency triggers, okay? In particular, the currency triggers are due to the fetching of rows in 4801 and 4801T that contain currency-sensitive data dictionary fields. In particular, the CO, the CRCD, and the CRDC. Good, you're not dyslexic, you can get all these fields, but anyway, there are, in the whole Enterprise One database, maybe 2 or 3 dozen or so data dictionary items that are deemed currency sensitive, that in order for them to run and format properly, in situations where apps need the currency to be correct, every call, you have to run triggers, okay? And this drawing has 3 of those fields, okay? You got 1 of them from the 4801T, 2 of them in the tag table. That means for every row you fetch from that big fat 3-table join, there's going to be 3 currency trigger calls per row. Again, these triggers are known, if you've done any analysis in the past or have some familiarity with E1 apps, they can be expensive, okay? There are 2 of them, okay? Here, that 4801 underscore currency, 4801T underscore currency. That is the protocol of how the currency triggers are named. They are C functions. They're stored in a DLL like business functions, but you won't see them in the debug logs. They are not visible in the call stack layer. Why is that? It's one of those things, I'll give you the answer that my college professors used to give me when they didn't have a good answer, and that's historical reasons, okay? Another one, it's intuitively obvious, right? Means when you didn't want to answer what was going on. But that's something I'd like to see change. But the bottom line is the 4801 currency is what calls the decimal trigger as a child. The 4801T also calls the decimal trigger as a child, then calls the 4801 company as a child. So all those calls with all those selects in the 4801 and the other calls to the decimal trigger at the lower level are all called by that tag table currency, okay? So all that work, okay, and all the time spent in that, in the runtime calendar business logic is just simply due to currency being on. So what do we do now? Well, answer turned out to be very simple, okay? What we got from development, you know what? It is not necessary for a business reason to have currency triggers on. Weren't necessary. And it turns out there's a very easy way of disabling them. There was simply one, they added this just basically one line of code into the set selection for Work Center, and that was a set request trigger options that says turn currency triggers off, okay? So none of them ran. Once we did that, boy, does that profile look different, okay? That with logging on, the set selection was reduced from 32 seconds to 1.6 seconds. We eliminated all the calls to the decimal trigger, the get 4801, all that mess is just pushed out, okay? The code is now a whole lot more streamlined. All the business function called by the offended / eliminating currency triggers have all been eliminated since the triggers themselves are gone. And all the inherent 4801 IO just were limited by being able to cut those triggers out at the top level by just one line of code that flips the switch, okay? So now, at going all the way to the user level, that refresh runtime was reduced to 1 second or less. Now the GUI artifacts, the busy cursor and whatnot, are probably longer than the business logic now. So again, one takeaway here is that significant performance gains don't always require open heart surgery on the code, okay? Sometimes the biggest, fattest performance gains is something very simple. Sometimes you can rip apart and refactor a code just to get a few percent, okay? So the amount of lines of code you have to go and look at and change and refactor or whatever, there's not necessarily a correlation to that and performance. A lot of code, if it's efficient code, can run very efficient, can run quickly. You can have a very little bit of code that can be, just god-awfully slow, especially if you've got indexes, inefficient SQL, and whatnot, okay? The answer is it just depends. Now, the second part of this project again, there's not only two parts. I'm giving you just a couple of phases of this testing to give you kind of general, that give you an idea of what we ran into and some of the things we're still looking at, with this ADF AIS testing, is load testing, okay? So now we got this ADF, at least for one person sitting down, punching the buttons at the computer, it can work well, okay? It responds less than a second, things work, that we got volume data set up, all of that's been done. But now what we want to do is stress the code under multi-user conditions. And, for curiosity's sake, we are using a tool called Oracle Application Testing Suite, or OATS. It is what we use now instead of we formerly used a product called LoadRunner, that suite of applications, but that's owned by HP. Okay? Oracle's product is called OATS, and that is a multi-user load testing scripting platform. But what we want to do here is measure and track metrics in this volume environment on the Java servers, such as JVM memory usage. And that's what we're going to focus on here, is the use of heap memory on Jazz AIS and ADF. Remember, there are 3 different Java managed instances on 3 different machines, okay? That means 3 different JVMs that are involved in just getting this ADF app to work. And in order for things to work well and to analyze things in this multi-user environment, you got to keep track of what's memory doing on all of these servers. Now, a little bit about memory usage in Java. If you know much about Java, this is kind of a review. If you don't, well, it's not as easy to track memory in Java as it is any other process at the OS level. Because what happens is the Java, the JVM manifests itself as a thing you'll see like a java.exe, okay? And when you see the memory profile it has, it'll just have, whatever you allocated on the startup, okay? That if it's a 2 gig JVM, you'll see just one process, boom, 2 gig, okay? And everything's happening within that black box, okay? From an OS standpoint, all it sees is a 2 gig process. It's a little bit more complicated than that, depending on if you've got the start and the max has different values. Won't get into everything about Java does memory, but all that's visible at the OS level is this 2 gig footprint, okay? So if you look at the interface of the WebLogic J2EE server, you can see there's a box for arguments in the server start tab that contains the JVM start parameters, the parameters you use to start that Java executable. Kind of here's what it would look like if you had started at the command line from Unix. You can see we're using, by the way, for the purposes of this, this use case used version 1.7045 of the latest JDK. And you can see to the XMS and XMX are the start and max heap size, which was 2 gig in both cases here. Okay, so all 3 machines had a 2 gig heap size, and that's what it used. Other jobs, again, that are part of the non-Java part of the ecosystem, mainly your Enterprise One jobs, Run Batch, your UVEs, your kernel jobs, your net jobs, you can trace memory in various ways. Unix, you can do utilities like PS-free, VMstat, top, and those will give you, memory profile data. There's also OS Watcher, which is a Linux utility. Windows, you can use Task Manager, perfmon collects data, and whatnot. So how do we track heap uses within a JVM? The answer is something called verbose garbage collection. Okay? And that can be used to create a JVM memory profile that is useful, okay, that shows you what the memory is doing. And to get that, you add 3 different parameters to your JVM startup. A path to the GC log, we call that X log C, and then 2 others, print GC details and print GC timestamps. And what I've done is I've highlighted those as they would occur in a pretty standard command line launching a JVM. Important takeaway there, okay, because this is how you can look at the memory going on. And the GC will then appear in the location specified by that log C parameter, or that log GC. Here I like to put it the same place where the other standard logs occur, so it's easy to find, okay. And here's what the log looks like. It is a plain text file. It records garbage collection events, their time, duration, and allocated used heap. Okay. And what do I do with this? Well, there is a tool called GC Viewer at a website. It's a free, what I should have put, very important, it is free. It's a free download, okay, very easy to use. And what it does is you can just open up one of these GC files, just unmodified, okay, and it'll give you a picture that looks something like that. And you can see the top part of this, if you can't read it, is 2 gig here, okay, so it shows you how memory is being allocated and freed over time, okay, over the particular time period you sample, okay. And the GC Viewer reads these logs and displays, again, key JVM memory parameters, in particular, the total heap, used heap, and full GC lines I find are the most critical. They're going to be the ones that are going to have the most activity and that are going to be most relevant toward memory problems, tuning issues, okay? The good thing about GC Viewer, you can kick out a CSV file, and that way you have the full capability of anything Excel can do, okay? So what you can do is you can easily change the scale, you can zoom in, zoom out, pretty up your graphs, that whole thing. In particular, I usually like to graph the used heap, over time, okay? That is the key relevant parameter to show the heap usage over time of a JVM. And as a point here, maybe this should have been a takeaway, but what you want to look at to determine whether or not a true heap leak is occurring is where are the low points of this graph? Where does the memory go back down to? Because every time the memory hits back down to this low point, that means you've seen a garbage collection, okay? It goes up, goes up, goes up, goes up, and then goes back down again. Now, if the low point is staying the same and not really rising rapidly, that's how you kind of, in very general terms, that's healthy JVM memory usage. And side note here a little bit, just scratching the surface on how Java manages memory, and the allocation algorithm is a little bit complex, has some subtleties to it, but the bottom line is, instead of having to call a free method or whether, what have you, where, those of you that come from the C world, you allocate something, you got to free it. If you don't free it, that is the most common source of memory leaks at a low level. Well, in Java, it's a little bit different. Memory which goes out of scope kind of accumulates and piles up until the JVM garbage collects it and releases it back to the system, okay? And this is what it continually does. Okay, now properly written Java classes will release their memory kind of behind the scenes via the GC. Okay, you don't have to do anything as a developer. The JVM does that. That's what the virtual machine does. That is one of the differences between Java and other languages. Okay, C code doesn't have anything like a JVM. Okay, whoever codes, has to go and, if it's C++, you've got to call your destroy method or whatever. Java does that for you. Different parts of the JVM memory pool have cool names like Eden and Survivor and Tenured, and one of these sessions I'm going to do a reality show, right? Who survived in Eden and whatever, but any event, You can read all about that. I should have put a link. There's good papers out there. But anyway, in very general terms, what you're going to find is the JVM will kind of over-allocate, and then what it'll do is you might see it, oh, wow, it's scary. It's going right to 2 gig right away. Well, not as scary as you think, because the apps, the code you're running might only use a tiny fraction of where the memory is actually at. But then Java, then under the covers of what it allocated, will then dole out memory from that big chunk. Okay, it's just an efficiency thing. So oftentimes, because you see memory going up fast isn't necessarily scary until you see a certain pattern, which I'm going to show you. Right? But anyway, back to our test. We ran a 100-user test of the ADF application, saw user failures. Bang, 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 bang. Users were just dropping, okay, everywhere. Okay. The AIS log showed this, a clear out-of-memory heap space. You can see sadness over there, whoever it is, from Inside Out is saying JVM memory's leaked. Can't get it back. Well, the good thing is in the real world we can get it back, but we're going to find out where the heck it went. Right? And here we have a picture of what leaked memory looks like when using GC Viewer. Yuck. What you have is the heap rises. Again, the fact that it rose is not necessarily a bad thing in and of itself, because it dropped back down again, but look at the first place it drops down to. It doesn't go back to where it started, does it? Okay? What happens, it eventually grows back up again, and then instead of going back down, it flattens out. You get that haircut, and then you see it, that's coincided by these big black lines, which indicates full GCs. Now, full GCs are very expensive, okay? And full GCs is what it resorts to when it doesn't have any more, okay? It wants to get more memory, but it doesn't have more memory because it has fewer and fewer chunks of memory that are actually out of scope or that are reachable because memory has, in fact, leaked and hasn't been made available to give back to the system because of the way, you know, things have been coded, okay? So in any event, this is the picture of what bad looks like. You get this flat. It's not going back down. It's going back up, up, up until it says I quit, okay? Continuously rising low points here are the fingerprints of a JVM heap leak. So what do we do about that? Okay, we know we got a leak. How do we find it? That's where we have another command line parameter that you can add to your JVM, and that is the heap dump on out of memory error. Okay, in addition to our print timestamps and GC details, you can dump a core, okay, when you get one of these memory errors, okay? And we did that, and you can see a core file then gets dumped out to the same directory where the Java executable is located. The file will be big. Ours was 2.7 gigs. But this, unlike the GC file, is not a text file. It's not human readable. But no fear, there is yet another free tool you can use to analyze that core file. That is called Memory Analyzer by Eclipse. Giving you the location there where you can download it. And that tool contains a pretty intuitive feature called Leak Suspects. Okay? And we ran our core file on this. Again, help from development subject matter experts. Once again, they come into the play. They can short circuit a lot of guessing, a lot of fiddling around with unnecessary things. But this person helped us out a little bit, and the problem quickly jumped out when the core was analyzed. And in this case, it was management MBean classes were the main leak suspects, okay? Well, what does all that mean? Well, that means that the AAS server reporting metrics to the JDE server manager had some classes that kind of weren't doing things in a kosher way with memory, that they were glomming memory and having it not go out of scope. This picture clearly shows that the biggest chunk of memory involved was the reporting metrics to JDE Server Manager. Okay, so we're getting warm. We don't know a specific method or whatever that was being called, but the basic test, the most basic test you can do is just take out the Server Manager metrics, you know, which is a relatively small number of places in the code that it did this. Just disable them all. Try a run with the metrics removed. Okay. Within a day, development gave us a new jar file to go and deploy. And drum roll, please. Boom. Now that same ugly heat profile, you can see what it looks like now, okay? That what we have is a very long GC cycle. You can see it started here and it goes way up to maximum. I'm like, oh no, it's leaking, it's leaking, it's leaking. It's going to go to 2 gig, oh, boom. But then after something like 22 hours, it went all the way back down to the beginning and then started back up again, okay? That is well-behaved memory, okay? A little bit different, and it is a whole lot more gradual than the other graphs look like over the same time period. But this means that we have found the leak, okay? This means that on AIS, now things are happening properly. Now, if you look at the other profiles, these are the profiles from the ADF and the JAS server for the same time period. They're much busier, okay? They're much chattier. The reason is AIS, back in the previous slide, all this is a traffic cop. It's just playing catch back and forth. It's not doing any real work, right? Well, the ADF and JAS, they're doing work. They're running application code. They're processing serialized objects. They're crunching big XML files. They're running code logic. So the GCs happen much more often and with more gusto. See, ADF, it's going up and down, but again, it's this bottom part you want to look at, okay? Now, the black lines here indicate full GCs. Those are expensive. Maybe something to look at later with scalability. As you can see, you can't even hardly see. It looks like one big solid stripe. But again, the bottom of it, pretty stable and steady over a 23-hour period. So those two are looking pretty healthy. So the bottom line is the general cause of the leak was identified. The Java developer, all they need to do now is just pinpoint exactly where memory wasn't being released from the way things are being called. And that, the bottom line is, but even without that fix, it allows valid load tests to proceed, okay? Because from the standpoint of our load tests, we don't particularly care about, you know, the relatively paltry number of server manager metrics that are being reported on, okay? That's our happy dance there. Now note, also, I probably could have put a call out on here, is that the verbose garbage collection and the heap dump features don't add discernible overhead to the JVM performance, okay? I recommend you have these settings on in your live environment. Just turn them on. That way, it can be a big troubleshooting aid that you can proactively generate these files and you don't have to as much reproduce problems, okay? You know, what you'll have is maybe a GC log that gets bigger over time. You know, you've got to manage, mitigate that. But again, if things crash because something's low on memory, the heap dump will help kind of leave a corpse, you know, that you can use to try to do an autopsy rather than trying to say, oh, okay, now we've got 110 users at the Dallas site, and after they've run for 3 days, this happens. Well, do you really have to do another burn cycle, or can you go right to the core file and maybe try, without having to reproduce it, see where it might have come from, what might have happened? So again, to be in charge of the JVM, keeping JDE customers happy all day. In your heap memory, if you use these tools, you know, will give you good memories, right? So conclusions, the takeaways. Remember low-hanging fruit, material facts. In this case, the JDE log and the platform change, you know, we mentioned in the first case study. Performance Workbench is a tool we use all the time, you know, because logs are a very good tool. Log file settings that determine whether or not you're overwriting logs or getting a full log, okay? Everybody lies. Don't trust what you've been told unless you verified it yourself. Product knowledge, business knowledge of the app, kind of what I call tribal knowledge sometimes. Okay, what's this app really do? The fact that it's glomming, you know, caches, is that just how this app works? Drill down analysis of profile data. Again, where is the code spending its time? SQL parse tool, kind of to determine cardinality of your SQL statements, to determine where caching or over redundant fetches to the database might be occurring. Development subject matter experts, critical. You know, you might not see things that are easy short circuits like we did in the first case study. You might not know the meaning, you know, of where memory is being taken up or whatever, but the development people can provide that missing piece. Answer may be simple. You know, make huge improvements in performance might be just a small section of code. You don't know that. And again, these arguments, the verbose GC and heap dump JVM arguments, just are the critical tools toward analyzing JVM memory and to looking at what happens when the JVM crashes. And then the memory analyzer and GC viewer are tools you can use to read those files, okay? So again, I always finish everything I ever do with the Onyx. That's performance. It's not about let's install the latest patch, let's do this, let's throw this mud against the wall, seeing what sticks. It's all about where's the code spending its time, okay? That's first principles of performance. And with that, and the prepared part of things are done. And I guess we managed to survive a Zoom, or this is my first time, using the Zoom conference software here, so I guess that worked. So,
don't be afraid of Zoom.
Yeah, well, it was a TV show on PBS growing up, right along with Sesame Street Electric Company. Those you who date yourself the same as me, maybe will remember that. So, but anyway, I don't know, did we have any questions or chats or what?
There was a few questions, but most people answered them themselves or waited for you to get to it. So
Right.
Just to recap, is there a function that can be turned off for decimal currency triggers?
And the answer is yes, we did actually specify that. There is a JDB set request options, I think it is. In the slide itself, we showed what that is. How do I get my slides to stop? There we go. Everything's just kind of going slow here. But yeah, we did have that. And just if I can find that real quick, I can just, and again, I'll make these slides available as well. But there is a tools function you can call from within the business function to do that. Where was it? Anyway, it is in there. It's a JDB set request option, set trigger off. Something like that. I'm trying to find the slide. Don't really see it. Java. 3.1.4. Well, here we got 2 gig. Again, the newer versions of Java go 2 gig. Is there reverse engineering to track open applications in E1 via WebLogic or the GC tool? Well, actually, performance, or rather server manager, you can go and see open connections. Let's see, I may have an example I can show you here right now via something if I've got it open. I've got, let me see, what do I have? There's a test is kind of a volume test I'm running right now. It may have something that's somewhat relevant here. Don't know if this exactly is the question, but you can go, I can go to my HTML instance, okay, and then I can go user sessions. Okay, when that comes up, you can see it'll show, and I think I've got something running with 150 users right now. No, it's kind of slow. And you can see here are my users, okay, and that there is a column here for open applications. And you can see here, I've got, if they got any applications open, they'll be listed here. And actually what I have is 300 users. I've got AIS users and HTML users. So let's see. This question, server manager, when looking at the enterprise server, there's a button, calculate memory limits. Windows, this shows blah on the run batch. On the AIX system, one would it show 2 gig? Well, again, so the question is, okay, if I look at how much memory, okay, calculate memory limits. Don't know if I'm actually familiar with that particular button, actually. Process detail. Yeah, I don't know about where calculate memory limits is on this. It'll show 4.75. Don't know, but what really determines, so basically a 32-bit system, okay, in 32 bits, okay, and if you're talking theoretically 4 gigs is the limit. That's what 2 to the 32 is, okay. Now on Windows, you don't have that amount actually available to you, that memory that an application or a process can allocate via heap. Okay, you only have about half that, because Windows says we're taking half of it, for system usage. Okay, you got 2 gig, do what you want with it. Okay, so really, essentially, the 32-bit limit is 2 gig for a Windows process. Now, for the different Unix platforms, it's a little bit different. Okay, for AIS, you can set it, to be as much as 2 gig. Okay, for other platforms like HP, well, it's not just as simple as setting it to 2 gig. You've got different parameters that control different portions of the heap memory, the stack memory can be so big and whatnot. So it's a little bit different, because you get memory that a process can grow to, but only a certain amount of it is heap space, which is usually when you dynamically allocate memory, doing things like cache and whatnot, you're actually using heap space. So it's a little bit more complicated. The bottom line is every platform does it different. The very general sloppy answer is that in a 32-bit system, which are the only systems the Enterprise One runs on at the moment, okay, you're going to have 2 gig per process, okay, maybe less, depending. That's kind of the very simple answer. The more complicated answer is different operating systems, have different, ramifications, different subtleties and nuances for how processes can allocate memory based on environment variables, OS tuning, parameters and whatnot. So the answer is a bit complicated there. Oh, sure. No, that's about it, probably. If there's any other questions, any other concerns, probably you can go ahead and forward those on to, Clayton can pass those on to me. Other than that, Clayton, there was a website that all of these presentations are stored on, available on, right? Or a doc.
Yeah, that's right, Chris.
Yeah,
we have a external Beehive workspace that most everybody should have access to, that we post the recording and the presentation to. So as soon as you give me that, I'll post it up there and it should be available.
Right.
I think we're out of time. Thank you very much for your presentation. Thanks everybody for attending. And we'll have another session in 2 weeks with AJ Papineau on IoT. Thanks, everyone.
Thank you.